Good morning. In the today's class, so we shall see the examples on surface integrals. In the last class, we seen the definition of surface integral and some very important remarks on this surface integral. That is, if surface is projected on xy plane, so how we can write ds. The projection if we do on yz plane, and similarly if you do on zx plane, then how one can write ds. That is. ds means that is what? The surface element. How one can represent the surface element that we have seen in the last class. So today we see examples on the surface integral, right? So first example here is examples. The first one, if f is equals to 2yi minus 3j plus x square k and yes is the parabolic cylinder y square is equals to 8x in the first octant bounded by the planes y is equals to 4 and z is equals to 6. Then show that integration over surface S f dot n cap ds is equal to 132 Yes. So this is the given example. So here they have given f, okay, and they have given that is the surface, that is what? Parabolic cylinder. So it will be y square is equals to 8x in the first octant bounded by the planes y is equals to 4 and z is equals to 6. Then we need to prove that is the surface integral is equals to that is 132. So now here first you write what they have given. Solution, let what is f is equals to that is 2yi minus 3j plus x square k. Call it equation 1, right? Next is the parabolic cylinder, okay? Parabolic cylinder. Given that parabolic cylinder y square is equals to 8x is bounded by the planes y is equals to 4 and z is equals to that is 6 in first octant. Okay. So now what is this? So how they are saying that for parabolic cylinder? Okay, cylinder means one can very easily understand. Okay, cylinder will be like this. Yes, so this is a cylinder. Okay, so but parabolic cylinder means what? Parabolic cylinder will be like this. Yes, parabolic cylinder will be like this. Yes, so we will call it as what? That is parabolic cylinder. Okay, parabolic form, so that will be a cylinder. So now here what they have given which will be bounded by two planes, that is y is equals to 4 and z is equals to 6 in the first octant. First octant means what? If you take x, y, z, okay, this is z, this is y, this is x, and this is origin. Then first octant means what? that is positive direction of x-axis, positive direction of y-axis, and positive direction of that is z-axis. Okay, so guys, I'll tell you. So if in case, so if you take this as z-axis, this as this as z-axis, this as y-axis, this as x-axis, then this is a first octant. This is first octant. That will be second octant. So third octant, fourth octant. And where are the remaining 4 octant? Because octant means what, that is 8 such a type of what the planes will come. Okay, 8 such a type of what the things will come. Then if these 4 you will get, this is 1, that is second, fourth, fifth. First, second, third, fourth. The remaining arcs they'll be below this. Okay, so therefore that's what total 8 will come. So this will be what, that is first octant, and they are saying that is the given the parabolic cylinder which will be in what, that is first octant. So here just I'll try to draw it. Yes, this is, so I'll take this one as x, this one as y, and here this one as that is z axis, and parabola means what, that you know, so it will be like this. Okay, so it might be like this. Yes, so now they are saying that which will be bounded by the planes z is equals to 6 and y is equals to 4. Y is equals to 4 is such a plane which will be, y is equals to 4 is such a plane which is parallel to xz plane. Okay, at y is equals to 4. Okay, so therefore this plane will be calling as what, that is y is equals to 4. Similarly, one more what the plane is there, that's what z is equals to 6. Okay, and that particular z is equals to 6. Okay, that is again one more plane which will be parallel to xy plane at z is equals to 4. So we can say. So now here what they said, that they wanted to they want us to prove this much. Okay, so this much already we have seen. So now whatever this f dot n cap ds is there, okay, whatever f dot n cap ds is there, so we need to project it on one particular plane, either on xy or yz or zx plane. Projecting it on xy or yz or zx plane means what, that is very important for us. Okay, so projecting means you have to see the shadow of this particular that is cylinder on that yz plane. Then what you will get? For example, if you get such a type of what the cylinder, and if you project it on yz plane, okay, from here if you project it on, that's what yz plane is here. If you project it on that, then what you will get? So that is we need to write in this particular example. Okay, so now before that, so first we'll find what is our n cap is. Okay, so n cap means what? First we need to find how one can find the n cap, that also we need to see. N cap means that is a unit normal vector. Okay, that is a unit normal vector on this particular surface of what, that is cylinder, surface of that is parabolic cylinder. So what is n cap we need to find. So therefore here I'll say that is first I'll say n vector, okay, not n cap, because n cap is what, that is unit vector. So first I'll find that is n, later will n vector, and later we can find unit vector of that n. So n is equals to, so how we'll find that's the normal vector to the surface, that is one can very easily know, that is by using that is gradient, that is gradient of grade of what, which grade of this particular parabolic cylinder, that is gradient of y square minus 8x or 8x minus y square we can say. So that means n cap is equals to, so gradient that you know, gradient means what, that is nabla 8x minus y square. Yes, you know, so how one can write nabla, gradient of this one, how will write, I dou by dou x of 8x minus y square plus j dou by dou y of 8x minus y square plus k dou by dou z of 8x minus y square. Okay, so now find it, that is dou by dou x, that is partial derivative of this. That means here you will get 8 times I, because this will be 0. Derivative of 8x with respect to x is 8. Next, plus here with respect to y, this will be 0 minus 2y. Y square is minus 2y j, and this will be now k is sorry here k we can keep as it is. With respect to z we are doing, but it is not there. There is no z term in that, so it will be 0. So therefore n cap I will write 8 times I minus 2y times that is j. So this we can very easily find. So next I want n cap. How will find n cap? N cap unit vector. N cap is equals to vector n divided by modulus of vector n. That means 8 minus 8I minus 2yj divided by square root of 8 square plus minus 2y square. That means n cap is equals to 8I minus 2yj divided by, that is square root of 64 plus 4 times y square. So this is your n cap. Okay, so we found n cap. So you can call it as equation number 2 if you want. Yes, it's equation number 2. So next what we want here, f dot n cap ds is there. F dot n cap ds is there. But ds we need to project it on either any of the 3 planes, either xy plane or yz plane or zx plane. So which is good for us to have that? So that we need to check. So now here next, that is f integration over a surface S, f dot n cap ds is equals to, so I'll project it on, that is yz plane. That will be best for me, because y is bounded here, that is y is equals to 4, and z is also bounded. Okay, somewhere here what z is also bounded, that is z is equals to 6. Okay, so therefore I'll project it on what, that is I'll be projecting it on, that is yz plane. So now here we'll get double integration over a region R. Okay, that region R will be on, that is yz plane. F I'll be writing, or else first you write f dot n cap into dy dz divided by modulus of n cap dot I. I is what, that is unit vector along, that is x axis, because here y and z are there, therefore so we are taking, that is the unit vector along, that is x axis. So now which is equal to, in double integration over R you write as it is, f you can write, so f is 2yi minus 3j plus x square k dot, what is n cap? N cap is here, this is n cap, that is 8i minus 2yj divided by square root of 64 minus 4y square, square root of 64 minus 4y square. Okay, next here it is dy dz we need to write divided by modulus of n cap. So again n cap we need to write this only, that is 8i minus 2yj divided by square root of 64 minus 4y square dot, what is I? Here I is there, just you write this I. Okay, so that we have done. Next, okay, so which is equals to double integration over R. Yes, so first this I, because it is a dot product, 2y into 8 plus minus 3 into minus 2y. So what you will get, that is 2y, and here this will be minus of minus, it is plus 3 into 6, that is 6 times, that is y will get, so close the bracket, divided by square root of 64 minus 4, sorry, plus it has, okay, not minus, this is plus, yes, this is plus, yes, even here also I have written plus, okay, so into, so 64 will come this side, that what you will get here, that is dy dz divided by 8 divided by, that is square root of 64 minus, sorry, 64 plus 4y square. These two now get cancelled. Okay, so then finally here integration over a surface here, f dot n cap ds is equals to, n cap ds is equals to, that is 2y plus 6y, that is 8 times y into dy into dz divided by, here we get 8, this 8 get cancelled, and now here this is double integration over a region R, y into dy, that is dz. Okay, so everything is fine. So now double integration is there, but we don't have the limits. Okay, that now what we need to do is we need to analyze the limits. Okay, so what limits we'll get, because here dy dz, if it is there, then from where to where y is running and from where to where z is running. Okay, so now if you project it on a yz plane, okay, if you project, that is what, parabolic cylinder on yz plane, then what you will see? You will see a rectangle. Okay, you will see a rectangle. So that is, in that rectangle, your y is running from 0 to 4 and z is running from 0 to 6. Okay, your y is running from 0 to 4 and z is running from 0 to 6. That one can very easily understand. So here now what I'll write is, that is integration over f dot n cap ds. So now here I'll write now y varies from y is equals to 0 to y is equals to 6, and x varies from z varies from z is equals to 0 to z is equals to 6, sorry, y is varying from y is equals to 0 to 4 it is, and z is varying from z is equals to 0 to, that is z is equals to 6. Okay, so now therefore integration over a surface here, f dot n cap ds is equals to, that is, I'll write first z is equals to 0 to z is equals to 6, and y is equals to 0 to y is equals to 4. Now y into dy into dz, yes, which is equal to, now integration of y with respect to y, that is y square by 2, z is equals to 6, that is y square by 2, and y is running from 0 to, that is 4 into dz. Then z is equals to 0 to z is equals to 6, then y square, that means 4 square. 4 square is what, that is 16 divided by 2 into dz. 16 by 2 means that is 8. So now integration over s f dot n cap ds is equals to integration z is equals to 0 to z is equals to 6, 8 dz. That means it will be 8z by 2, then z is running from z is equals to 0 to z is equals to, that is 6, z is equals to 0 to z is equals to 6. That means, one second. And there is a small correction. I think I have made a small mistake. Here it is 8i is there. Here it is 8i is there. Yes. So here I have made 2i into 8, it is 16. Sorry, this is 16. 2i into 8. So 2i into 8 is, that is 16. Then it is plus 6, that is correct. So instead of what writing that 8, it will be, instead of what writing that as 8, that will be 22. Okay, sorry. So this is, here there is a small correction. 8 you can keep as it is. Here this is 22y. Okay, so 22y means here I'll write 22 by 8, because 22 and 8 I'll be taking it outside. Then now you can write here this is 22 by 8 we can write, and here also it is 22 by 8. Here also it is 22 by 8. So now, okay. So here it will be 22 by 8 into 1 by 8 integration z is equals to 0 to z is equals to 6 into, that is dz, into dz, it is 8. Okay. So now 8 get cancels. Here it is 22. Then z is equals to 0 to z is equals to, sorry, integration of dz, that is z. Then z is running from z is equals to 0 to z is equals to 6, that is 22 in the bracket 6 minus 0. 22 6, this is 12, 2, then 12, it is 30, 130. Okay, so like this we can evaluate, that is surface integral. So therefore we proved that, that is f dot integration over s f dot n cap ds is equals to 132. Sorry, here I have made a small mistake. You can very easily understand. Here it is 2yi, here it is 8i. So 2i into 8 means that is 16y. Okay, minus 3 into minus 2y, that means plus 6y, plus 6y. So that's why it is 22 will get. So here I have corrected, and finally the answer we have got is, that is 132. So like this we can solve many examples. So these examples are little difficult when we compare with the what that is line integration, but still one can very easily do. Only here what you need to do is the projection, that is projecting the surface on xy or yz or zx plane. By projecting that, so what limits you will get, that we need to analyze. Okay, if you analyze that, then one can very easily solve these kind of examples. But here still the geometric understanding is also very important about what this given the data. So if you can analyze these things in terms of geometry, then one can very easily allocate the limits for the given values, right? So now I'll take up second example. So let me see that. Example number 2, evaluate integration f dot n cap ds over a surface S, where f is equals to xi plus z square minus zxj minus xyk, and S is the triangular surface with vertices with vertices 2, 0, 0, 0, 2, 0 and 0, 0, 4 and 0, 0, 4. Right. So you can see evaluate, that means we need to find the value of this. In the previous example we proved that this is equal to 132, and now here we are evaluating. So how much value of this we need to find, where f is given and s is a triangular surface with the vertices these 3. Okay, so now the solution, let's first write what is f. F is equals to xi plus z square minus zxj minus xyk, and call it equation 1. Call it equation 1. So now here the given is a triangular surface with the vertices. Okay, so this is passing through these 3 vertices. That means it is a plane which cuts x-axis at 2, y-axis at 2 and z-axis at 4. Okay, see, which cuts x-axis at 2, y-axis at 2 and z-axis at 4. This is a plane. We need to find the equation of the plane, right? So now the given plane passing through 0, 2, 0, 0, 0, 2, 0 and 0, 0, 4 is x by 2 plus y by 2 plus z by 4 is equals to 1. Here I'll write, because if you have a x, y and z intercept, if a is a x intercept, y is a b intercept and c is a z intercept, then equation of a plane is x by a plus y by b plus z by c. Z by c is equals to 1. So that's why a intercept, c, x intercept is, that is 2, y intercept is 2 and that is z intercept is, that is 4. So therefore we have written like this. Now simplify this. What is LCM? LCM is 4. One can very easily understand. This is 2x plus 2y plus z is equals to, that is 1. Then which implies that 2x plus 2y plus z is equals to 4 is the equation of a plane. And how it will pass us? So here I'll draw. Its geometry is like this. X, oh sorry, y, this is x, this is y and this is z axis and this is origin O. So here I'll call this as some point A 2, 0, 0, or else later I'll allot. Here this is point B, this is 0, 2, 0 and this is point C. What is this? 0, 0, it is 4. Now join them. Yes, so this is a plane. Okay, so which cuts x-axis at 2, y-axis at 2 and z-axis at 4. That means you can call it as like this. That is, it is 0, b, 0. This one you can call a, 0, 0, and this you can call 0, 0, that is c. So like this you can take that particular what the surface. Okay, surface is what, that is plane, that is curved plane. So it will be like this. So now by taking this plane we need to find first, that's what, n cap, right? So next what is n cap? That means first you find vector n, that means gradient of what, this plane, 2x plus 2y plus z minus 4. Okay, therefore how will I write? That is n n vector is equals to I dou by dou x of 2x plus 2y plus z minus 4. Similarly, plus j dou by dou I of 2x plus 2y plus z minus 4 plus k dou by dou z of 2x plus 2y plus z minus 4. Okay, then vector n is equals to how much it is with respect to x. If you differentiate, here you will get 2 times I, here you will get 2 times j, and here you will get 1 times k. And what do you want? That is n cap. N cap means n vector n divided by modulus of n. That means 2I plus 2j plus k divided by square root of 2 square is 4 plus 2 square is again 4 plus 1 square is 1. Then here you will get, that is n cap unit vector is equals to 2I plus 2j plus k divided by, that is square root of 9 means it is 3. N cap is 3. Yes, can call it equation number 2. Yes, we found that is n cap. Okay, done, no problem. Then separately shall we find ds? That means you can project that given plane either in xy plane or in yz plane or in zx plane. Okay, that is left to you. So if you do that, so for instance, just to consider, if you project it on xy plane, okay, if you project it on what that is xy plane, then what you will get? You will get a triangular region. For example, this is x and this is y, and if you project it on this, well, then what you will get? So it will cut your given what the plane like this. Then that line equation we need to find. Okay, so this equation we need to find. So later we can find that. So before that, if you, so first thing is that we are projecting that given plane on the given this plane on that is xy plane. So therefore ds is equals to, if you project it on xy plane, then what you will get? That is dx dy divided by n cap into k. K is what that is? Unit vector along z axis. Okay, so therefore ds is equals to, that is dx dy divided by n cap is already here, and with that if you do with this k, then what you will get? These will be zeros, only the coefficient of k will remain, that is 1 by 3. So here we'll write 1 by 3. That means ds is equals to 3 into dx dy will get. Okay, 3 into dx dy will get. So now next I'll go to what that is surface integral. Now by the definition of surface integral, that is integration over surface, yes, f dot n cap ds is equals to integration, that is double integration over a region R. So f is there, you can write, that is xi plus z square minus zxj, okay, minus xy k dot, what is n cap? So n cap is here, that is 2I plus 2j plus k divided by 3 into ds is 3 into dx dy. This 3 get cancelled. Now these two if you combine, what you will get? That is double integration over a region R, x into 2, that is 2x, then this whole thing, that z square minus zx into 2 plus 2 into z square minus zx, x minus xy plus 1, that is minus xy, here into dx into dy will get. Okay, so now here the point is, only we will be having what, that is double integration with respect to x and y, but here z is there. Then how to eliminate that z? Because I don't want z in this particular integral. So how to eliminate the z means, here you have an answer. Yes, that is, if you convert, that is z in terms of x and y, what you will get, that is 4 minus 2x minus 2y. Okay, this is your z. So now we can use that z in this particular what, that is equation. That means double integration over a region R, this is 2x plus 2 into that whole z. So you can use 4, this is 4, yes, this is 4 minus 2x minus 2y whole square minus x into 4 minus 2x minus 2y, and here it is minus xy into dx into dy. Okay, and its simplification leads. Okay, directly I'll write its simplification because it is a very lengthy simplification. So therefore directly I'll write here, that is the simplification. Okay, so integration over a surface S, f dot n cap ds is equals to f dot n cap ds is equals to double integration over R 2x, sorry, 12 times x square plus 8 times y square plus 19 times xy minus 38x minus 32y plus 32 into dx, it is into dy. Now if you project it on xy plane, then your x will be varying from x equals to 0 to x equals to 2. That one can very easily understand. Okay, and here this is x equals to 0. But y is varying from y is equals to 0 to y is equals to this particular, that is what, line. Okay, so therefore in yes, in the xy plane, right? In the xy plane, x varies from x equals to 0 to x equals to 2, and y varies from y is equals to 0 to y is equals to. So this is little the difficult task that we need to do. That means what, here x intercept is 2, y intercept is what, that is also 2 only. Then how one can write? Yes, that is x by 2 plus y by 2 is equals to 1, we can write. Okay, directly we'll write otherwise. So y is equals to 2 minus x. So here I'll write because x by 2 plus y by 2 is equals to 1, which implies that x plus y is equals to 2. So therefore y is equals to 2 minus x. So because of what, this reason, that is y is running from y is equals to 2 to y is equals to 2 minus x. That means this particular the equation of this particular line is y is equals to 2 minus, that is x. So you can write it like that. So now if you integrate it, now integration over s f dot n cap ds is equals to, first I'll write x equals to 0 to x equals to 2, and here I'll write y is equals to 0 to y is equals to, that is 2 minus x. Now you can have this, that is 12x square plus 8y square plus 19xy minus 38x minus 32y plus 32 first into dy into dx. Now integrate it, that is integration over x equals to 0 to x equals to 2. Integrate this with respect to y first. That means 12 x square y, here it is plus 8 y cube by 3 plus this will be 19x y square by 2 minus 38x y minus 32 y square by 2. Y square by 2 means 32 means it is 16 16y square, then here it is plus 32y. Okay, so now y is running from y is equals to 0 to y is equals to, that is 2 minus x into dx, okay, which is equals to x equals to 0 to x equals to 2. Now put upper limit, that is y is equals to what, 2 minus x. By putting upper limit, so what we'll get, we'll see. By putting lower limit, that whole term will be 0 only. By putting upper limit, so what I'll get, I'll write here because it's a big calculation. So therefore this is 24 times x square, sorry, x square is 24, 1 second, yes, minus 31 x cube by 6 plus 24 x square minus 38x plus 64 by 3 into dx. Okay, so now again with respect to x, if you integrate, then we'll get minus 31 by x raised to 4 by 6 for the 24, yes, plus 24 x cube by 3, and here it is 38 x square by 2 plus 64 by 3, and x is running from x equals to 0 to x equals to, that is 2. Now put upper and lower limit to this, then integration over surface s f dot n cap ds is equals to, put upper limit, then here you will get minus 31, here it is, so directly I'll write minus 62 by 3 plus 64 minus 76 plus 128 by 3, and for lower limit that will be 0, one can very easily understand. Therefore the final answer is yes, integration over surface s f dot n cap ds is equals to, the final answer is, that is 10. If you want to analyze, you can analyze it. The final answer is, that is 10. So this is the second example, so how one can do on the surface integral. So one more example is there, hope you people will do this. Yes, this is a big example, but everything is explained in this example number 3. I think you can understand because already I have taken 2 examples on this particular surface integral. So now I'll go to next concept, that is volume integral. Okay, simple, that's what the volume integral they have given as a definition. Okay, not they have not given any examples on this. Simply we need to see what do you mean by that is volume integral. Okay, so how one can understand this volume integral, so we need to see this. Yes, and later on so we'll go to, that is Green's theorem. From that Green's theorem we'll see examples. Yes, so now we'll take a volume definition of volume integral. Yes, that is volume integral. volume integral. So first you write down what do you mean by volume integral. Consider a continuous vector point function f is equals to f1i plus f2j plus f3k in the region E, in the region that is capital E, enclosed by the surfaces, enclosed by surface yes, then volume integral of f over E is written as, that is, integration over a region E f into dv. That is, dv means what? That is volume element. Okay, so we seen line integral. Okay, we seen that is surface integral. Okay, we have taken a surface and then we seen surface integral. Then next now it is a volume integral. Volume integral means what? That is a small element. Okay, small element in the what? That is volume we are taking. So how will write? Or volume means region E, so we need to write it as what? That is triple integration. Volume means what? That is a triple integration. It will be bounded by what? That is x, y and z axis. So therefore that is a volume. Or triple integration over a region E, f into dx, dy and that is dz. Okay, so if you elaborate it, or so how one can write? Triple integration over E, f is what? That is f1i plus f2j plus f3k into dx, dy, that is dz. Okay, then that is nothing but, so I will write triple integration over a region E. So here I'll write I outside, or else here you can take f dv over E, that is equals to I f1 dx dy dz plus j into triple integration over E f2 dx dy dz plus k into triple integration over E f3 dx dy dz. Okay, so like this we can integrate and we can find that is volume integral. So here one thing what we need to understand is, for example, here this f is not there. Okay, that means what? If this f is a constant one, then what will be the answer? Okay, that is nothing but, that is the volume bounded by x, y and z, x, y and z. Okay, so here if you allot what the limit for x from some value to some value, y from some value to some value and z from some value to some value, then that will be a volume of that. But when if you put f, then that is volume integral, but that is not a volume. That means what? That is here f is there. F is a vector field or a vector point function which is defined in the, that's what, the closed surface. Okay, so how volume will be created? That is by a closed surface. For instance, you consider that's what, a sphere. Okay, sphere is a closed surface. Okay, sphere is a what? That is closed surface. Okay, in that closed surface inside there is a what? Volume, and that they are saying. So and whatever the inside the region is there, that will be called as what? That is E. Okay, so like this they'll be defining. For example, if you get a hemisphere, okay, then that is not a closed surface. then there is no meaning of what that is finding that is volume in that. But here it is what, if you get any closed surface, then inside that there is a region, and that region is called, that's what, that region is the volume. Okay, that one can very easily find on this particular what the concept. Okay, this is the definition of what that is volume integral. And in the next class we will see, that is Green's theorem, Stokes theorem, and Gauss divergence theorem. If you do, if we understand, so what is Green's theorem, its definition, examples, Stokes theorem, definition, examples, and Gauss divergence theorem and its definition and example, if you do, then that will be the end of this unit number 2, vector integration. So in the next class we'll see, that is Green's theorem. Okay, yes.